So the second question here asks about when is a function decreasing? When is the function increasing? When I see the words increasing and decreasing, I think, well, when is the derivative positive? Because if the derivative is positive, the slopes of the tangent lines are positive, so the curve is going up. And conversely, if the derivative is negative, the curve is going down. So I'm going to find the derivative. When I look at this particular function here, I look at finding the derivative, I think about the product rule. So I'm going to take the first factor times the derivative of the second, plus the second times the derivative of the first. We know the derivative of e to the stuff is e to the stuff times the derivative of stuff. So we use the chain rule here. And the derivative of e to the x is just 1. I think there's a common factor between those two terms. Common factor being e to the negative 2x. We can pull that out and we get 1 minus 2x for the factor that's left inside the parenthesis. So now we can set this stuff in the brackets here equal to 0 to find our critical point. We'll get that the critical point occurs at x equals 1/2. Again, there's no time when e to a power will ever equal 0. So as far as our critical points go, we just have a critical point at x equals 1/2. So we're interested in determining, when we look at the derivative, whether the derivative is positive or negative. And we know that the derivative of the function at x equals 1/2 is going to equal 0. And if I pick a number larger than x equals 1/2, such as 1, and plug that in here for x, I'm going to get a negative 2 times plus 1. So I'm going to get a number that is negative out of the brackets, and e to a power is always positive. So when I take the positive factor times the negative factor, I get that the first derivative is negative. If I pick a number that is less than 1/2, such as 0 for x, both factors will be positive. E to the 0 is 1, 0 plus 1 is 1. So I get a positive value when I put in numbers that are less than 1/2. When the derivative is negative, that tells me that the curve is decreasing. The function is decreasing when its derivative is negative, when the slope of the tangent lines are negative. The function is increasing when the derivative is positive, and the slopes of the tangent lines are positive. So, to answer the question then, we can say f increases on the interval from negative infinity to positive 1/2 because the derivative of f is greater than 0 on that interval. Because f prime is greater than 0 on that interval. Then we can say that the derivative of the function is negative on the interval from 1/2 to positive infinity. So f decreases on the interval from 1/2 to positive infinity because the derivative is negative on that interval. So that would be our answer to part A. Part A asked when is the function increasing and when is the function decreasing, and we use the derivative to find that. Part B asks about absolute mins and maxes. Part B asks about the absolute min and the absolute max of the function. So we know that the candidates for absolute extrema are the endpoints and the critical points. So we know our only critical point is at 1/2. And we know the endpoints are at 0 and 10 on this interval. So let's plug in the critical points and let's plug in the endpoints. So absolute maxima, absolute minima occur at critical points or endpoints. So, our critical point is at x equals 1/2. When I plugged 1/2 in for x, I get a little more than 0.18 for the answer. The endpoints are 0 and 10. I plug that back into the original function, and I get 0 and 10 times e to the negative 20th. We can see that the value of the function here is really close to 0. The value of the function here is 0. So this place right here would be our maximum. It's the biggest of the critical points, y values, and the endpoints, y values. And the minimum would be the smallest of the critical points, y values, and the smallest of the endpoints, y values. So in this case, that would be at 0. So the absolute max is at 1/2 e to the negative 1. And that's at x equals 1/2. And the absolute min is at 0. And that's when x is equal to 0 as well. So I hope that helps you with the two AP review questions.